two variable inequalities. So let's talk about some Algebra 1 review. When you graph a less than or greater than, it's going to be a dotted line on the coordinate plane. Less than or equal to or greater than or equal to is going to be a solid line. When you have y is less than or y is less than or equal to, we're going to have to shade, and it tells us since y is smaller, you want to find the y-intercept and shade everything lower than the graph. If y is greater than or y is greater than or equal to, you want to find the y-intercept, and since y is bigger, you want to shade everything above the graph. Let's go ahead and look at some inequalities on the coordinate plane with one variable. When you see y is greater than or equal to 3, remember when you only see the y and you don't have an x, that means we're going to have a horizontal line. So you find positive 3 on the y-axis, and then from here. So now we want to graph inequalities in two variables on the coordinate plane. So we're going to take the inequality and we need to change it into slope-intercept form. So we subtract 3x from both sides. We have 2y is greater than or equal to negative 3x plus 2. And then we want to divide both sides by 2. So we have y is greater than or equal to negative 3 halves x plus 1. And then we want to plot this on the coordinate plane. So put your slope first, your y-intercept first, and then we're going to use the slope to plot a couple more points. And then we can go ahead and plot that line, and this one's going to be a solid line. Then we need to shade. So since y is greater than, we're going to find the y-intercept, and then you want to shade everything above the graph. In example 4, we need to do the same. Put this into slope-intercept form first. So subtract 2x from both sides. We have negative 2y is greater than negative 2x minus 6. Divide everything by negative 2. Now, as we do this, remember, when we're working with inequalities, whenever you divide or multiply by a negative number, we need to flip the sign. So make sure to do that. Then we're left with x plus 3. So we can plot our y-intercept, positive 3, and then our slope is positive 1. After you get a few points, you can go ahead and plot your line. Just remember, this is going to be a dotted line. And then when we shade, y is smaller, so you find your y-intercept and you shade down everything below the graph. Lastly, we're just going to graph a couple of our absolute value inequalities in two variables. So this also takes into account the absolute value equations that we were graphing in the previous lesson. So first, we need to find the vertex. There's no h, so we have 0. Our k is positive 3. And then this negative tells us it's going to open downwards. We have a slope of 1. So plot your vertex, 0, 3. We know it's going to open downwards with the slope of 1. So we go down 1 over 1, down 1 over 1, and then same thing on the left side. And then we can go ahead and plot a dotted absolute value. Then lastly, we want to shade. So you find your y-intercept, and we want everything smaller. So everything smaller is going to be inside of that v, underneath. So one last example. The y is on the right side, but that's okay. We're going to find our vertex first. Remember, h is the opposite, so we have positive 1. We have no k, so it's 0. This is positive, so it's going to open upwards, and we have a slope of 2 over 1. So you plot the vertex, and we know it's going to open up with the positive slope of 2 over 1, so up 2 over 1 on both sides. Then we can go ahead and plot a solid line absolute value function. And then lastly, for our shading, remember what we talked about. This is open to this side, which means y is going to be smaller. So we find the y-intercept, and all the values smaller are going to be outside of the v. So that's what we're going to shade. That's it for this lesson. I'll see you in class for more practice.